Hello people, this is tutorial number 13. I will be creating a very simple gear train mechanism, and I will be using the gear joint and rack joints that are available in the 3D Experiences kinematic solver. What we have here is a a pinion gear, the small gear, and which is driving that big gear, and that big gear is driving the rack that's shown underneath. Now, of course, I will not be using the gear teeth because that is not the point of these tutorials that I'm preparing. This is all going to go into a playlist which is called Kinematic Scene 3D Experiences platform. Now, tutorial 14 is a repeat of this tutorial, except that I will not be using gear and rack joints. Instead, I will be using what is called a roll curve joint. Uh, I really don't need any dimensions in this problem, except that since I want to check some physics, I will assume that the radius of this big gear is 30 millimeters and the radius of the small gear period is 10. And why I do that is because later on I want to specify, for example, the small gears uh, uh, RPM to be 180, and the ratio of which is incidentally 18.85 rad per second. Now we know that the big gear is going to be spinning at a smaller rate, which is the ratio of the small radius over the big radius. So the big gear is going to turn at only 2 pi rad per second, which is 6.28. Now, from elementary physics, if we multiply this rad per second by 30 millimeters, we're going to get the linear velocity of the rack, which at the end of the day, if I specify 180 RPM for the small gear, I should be getting the velocity of the rack to be 188 millimeters per second. This is the chapter 8 of the textbook here that was prepared about 8 years ago, and since it's not revised, I will be basically revising the book in the form of these video tutorials using the release 2024X of 3D Experience. Okay, let's go ahead and make it. Okay, let me go to the mechanical assembly design workbench. Assembly design workbench. First, I'm going to make the the wall. So right click, insert 3D part, and I'm going to call this thing wall. At least put a prefix wall next to it. Wall. And here is the instance, also wall. Let's go make it. So double click on that. On a convenient plane, on this vertical plane, I will sketch something, a rectangle. And let's say this is about 140. This is about, no, let me dimension these things so that we can see what it is. This is 100 and 100. Okay. So fine. 102. So now I'm going to make these holes here where the gears are going to go into. So let me go ahead and make a circle there. And I'm going to dimension this to be, what was that, 5 millimeter? Make 5 millimeters. Okay. And then 40 millimeters away, I'm going to make another hole with the same radius. Okay, so let me dimension this thing to be the same. These are not critical, except that I want them to be 40 millimeters apart because the radius of one of the circles is uh, uh, 30, the other one is 10, so they're 40 millimeters apart, the center. Okay, good. I may have to resize this thing so that it's more respectable. So maybe we'll do that later on. Okay. And now, oh yeah, okay, so what I'm going to do is actually make these distances 40 millimeters away from here, just for the sake of bookkeeping so that we know what it is. So 40. Very good. Okay. Now, exit and pad it. I'll make it 10 millimeters. Okay, so this is going to be the wall. Now I'm going to go insert the big gear. So insert 3D part. I'm going to call this thing big one. Properties, put a big over there. And big over here. All right, let's go make it. Double click on 3D shape on a convenient plane. On that plane, I will sketch. You know what? I'm going to project that circle so that I reduce it by one step. So I'm going to project that circle. Okay. And then draw the rest of the thing, the rest of the gear. So it's going to be a circle centered right there, radius 30. Okay, so let me make that radius 30. Good. Now exit. Okay, so yeah, exit. You know what? While I'm here, I'm going to make a little indentation, a little circle here, which eventually I'm going to pocket it out so that at least you can see the rotation of this thing very clearly. All right. I want to do a multi-path here, so I go to multi-path. Okay, so there's there's three curves here. So this first one, if you look at this first one, probably is the big circle. So let me pad it by 10 millimeters, see whether it is actually, no, that is actually the hole. You can see that. So I'm going to make this thing the zero, sorry, it's the hole. This is probably 10. Yep. Okay. And I'm going to flip yeah, that's fine. And this last one is the shaft, which I'm going to make it maybe 20. And it goes in the other direction, right there. Okay, so that's fine. Actually, let me make this thing 30. Good. Okay, I'll do exactly the same thing with this other fellow. So all the way to the top, right click, insert 3D part. And I'm going to call this thing the small one. Properties, small. And same thing down there. Actually, small. Too many else. And this one is also small. Okay. And let's make it same process. Double click on that plane. I will sketch. Why don't I project that circle? This is just to cut down one operation. So there we are. And then a circle of radius 10. So the view from the front. So circle. I'm going to make this in radius 10. And that makes the two tangent to each other. Good. Exit. And once again, a multi-path. Oh, I forgot to do that circle. So let me that little hole there. So let me make some marker here. So maybe a little circle there. Okay, now exit. All right. So multi-path. Where is it? There. Three arcs. So it's kind of hard to see what's going on here as far as who is who. So let me actually hide this. Okay, good. So this one, if I put a 10, for example, that's going to be that thing which I want it to be actually whole. So I put a 0. This one is, I'll make this thing 10. See how it looks like. Yep, that's fine. And this one, I think I made it 30. Not? Yeah. That's what that's what we have. Good. All the way to the top. Now let's insert the the rack. So let me put this thing in the front so that we can see it. There we are. And now all the way to the top, right click, insert 3D part. Let's call this thing the rack. Properties, rack, and rack. Okay, let's go make it. On that plane, I will sketch. All it is basically a rectangle which is padded. So I'll do it like that. Okay, so I want this guy to be tangent, coincident with this. This control that, and we make it coincident. Good. And now I want this fellow to be tangent to that. This control this. Sorry again. This control with that arc. Okay, it's kind of hard to select that arc, and the reason is that this is blocking us. So let me hide that fellow. Let's try it again. So this horizontal line control that arc, and we want to make them tangent to each other. With that wall sitting right in front of us, it will not let us do that. So let me bring this thing in the front. There we are. And I'm going to exit and pat this thing by 10 in the other direction. Let me do that in the other direction. So 10. Yep. Good. Okay, now we're just going to have to create the appropriate joints here. So let me actually go ahead and do the following. Move these a little bit. So I'll use the compass to do that. I'll put it there. Okay. Very good. Okay, first thing we're going to do is we're going to fix this wall. So under assembly, excuse me, fix the wall. Now let's create a revolute between this and that. So see now, revolute. And the way I'm going to make the revolute is axis and axis, plane and plane, and then for the command, I'm going to use the angle between two planes, appropriate planes. So I'll use this template. Let's do that. So this axis and that axis, this plane and that plane. Okay. And for the angle, I'm going to control, for example, the XY plane of the wall and the XY plane of the big gear. Okay. You know. Now do the same thing with the other fellow. So revolute between again. This is the template that I use. This axis and that axis. This plane and that plane. Okay. And once again for the angle, I'm going to use the XY plane of the wall and the XY plane of the small gear. I mean, there are other things you can do, but that's what. And no. Now we put the rack in there. It's going to be a prismatic joint. And for prismatic, I will use, for example, again, I'll use, which one do I like? I like, this is fine. Either this or that one. No, hang in there. This one. I like this. So this line and that line. And for example, this plane and that plane. And finally, for the offset, I'll use this end and that end. Let's say okay, and no. All right, so I think we have done everything that was needed. We can also check the stuff right here, by the way. Uh, if you want to, you can, but I'm not going to do that. So I'm going to go and create my mechanism. So mechanical systems design, and create your mechanism representation. Uh, yeah, so created, and now check it out. There's I forgot to fix something. So let me see now. Let me go ahead and fix this thing. Forgot to do the fixation. So here fix. I thought I did it, but anyway, I'm going to fix the wall. Okay, good. Now if I go there, you see that the fixed part is added, but I have to include it there. Okay, good. Now notice that. Let me try it again. I have 3 degrees of freedom because this revolute has one, the other revolute has one, and the prismatic has one. And if we try to see that, if you click on mechanism player, you see three sliding bars, one for the big gear, one for the small gear, and one for the prismatic thing. Reset. Say okay. Good. All right. Now what I want to do is add my gear joints right here. Okay. So if you go to the list of engineering connection, you don't see any gear joint here, but what you can see is engineering connection. And if you use a pull down menu, you're going to see gear. Notice what it's asking is two revolutes. So the revolutes, I can select it from the tree, for example, the big one and then the small one. Okay, now you have to specify the gear ratio. The gear ratio is 30 to 10. So what I'm going to do, the input is here. So you click on this icon. See that you click on this icon. You select the input, and then you select the output. And if necessary, you put a minus sign either here or there to give you that they're going opposite direction. And that's what this thing is about. Okay, that's what this poster is about. So I'm going to go and, or that's what that slide was about. So I'm going to put a minus sign here, and then we say okay. Good. So now if you go to your mechanism, notice that the gear joint has been created but not added. So I'm going to select this. I'm going to take away this prismatic joint, and then see what it is. The degree of freedom is going to be 1. Okay, now the only thing is that let's go ahead and see this. Okay, now the fact that I have two sliding bars here, I don't like it. So let me close this thing. Go to the mechanism manager. Notice that Revolut 1, which is the big gear, it says angle driven. I don't want this thing to be angle driven because the only thing that dictates the motion should be the pinion one. So if I uncheck that, see that if I uncheck that, this one is fine. The second one is okay. But the first one, which is for the big gear, I uncheck that and I say okay. Now when you click on the mechanism player, there's only one sliding bar, and it's only the motion of the big and small gears. Okay, you can see that, and they're going opposite direction, and the smaller one is turning uh, 3 times faster. Okay, so reset. Good. Now let's go ahead and create our rack joint. So we click on the engineering connection, select the rack joint, user defined, select the rack joint. Notice that what it's asking for is a prismatic one, and there is my prismatic one, okay? And a revolute one, which is the small one, the small gear, right there. Now to select the appropriate gear ratio, in other words, how much does this thing advance for every turn of the, well, actually, I'm sorry, this should have been the big gear, okay? Because the rack is driven by the big gear. Cancel that. We try it again. Where is that? Right there. Rack join, rack join, the prismatic one. And the revolute is going to be the big gear. And to get the correct advancement for every rotation of that, you click on the icon, select the circle, big circle, and it gives you the ratio that's needed to calculate that. And then you say, okay. Now, if you go here, if you go to this mechanism manager, notice that I added a rack, but the rack has not been created a rack, but it not be added there. So I select that, okay, and then I say, okay, let's check it now. Click on that, and notice that for every rotation of pinion, the rack, the bigger gear is going to turn a third of the way, and that will advance the rack. Now, this is fine, so let's go ahead and create the scenario and put some physics into this thing, okay? So we're going to go to mechanical system experience. Okay, we create our basically simulation. Now let's click on this low excitation and select that command for the pinion right there, and you put f of x there, and this is what will make it 120, right? What was, I can't remember what was that thing. 180 rpm. Okay, so let's put it in. I don't need this thing, or I can add to it 180 turn underscore minute min times time. There's time. This is 180 rpm. Say okay. Say okay. Now let's create a probe, for example, the velocity of this tip. So click on the position and speed probe, select that point, and say OK. Now we go create a kinematic scenario. There is a law, formula 180 RPM basically, and there is the probe that I created. Let's do it over a 2-second interval, because 180 RPM means 3 turns in each second. So let's do it over three seconds. If necessary, we're going to fix this thing. 0.05 and say OK. And we're going to run it. It went too far, but that's okay. No problem. So let's go ahead and plot this. We want the velocity in the or magnitude of the velocity, or the velocity in the y direction. So deselect everything and magnitude of the velocity, and that better be 188 millimeters per second. Right there. 185, this is 190, 188 millimeters per second, which agrees with this calculation. All right, folks. Good luck. I will, in tutorial 14, I'll repeat the same problem, except that I will not use the gear and rack joints. I will use roll curve joints.